to solve these, the very first thing we want to do is we want to take the linear value that's underneath the square root and say it has to be greater than or equal to 0. So we would go, because we have zero restrictions, so 2x minus 1, because it's underneath our square root, has to be greater than or equal to 0, because we can't take a negative. We'd add our 1 over, and we have to have 2x is greater than or equal to 1, and then we divide by 2, and x is greater than or equal to a half. That's our restriction. We can't have any values that are less than a half, right? Or else we get a negative underneath the square root. So when we have a single radical, which was yesterday's lesson, when we had a single radical, our first step is to do what? Isolate the radical. So we need to move the 5 by subtraction. So we get root 2x minus 1 equals 7. What's our next step? Square the square root to get rid of it, right? Make sure you're not on your phones. I see a few of you on your phones thinking you're sneaky, but you're not. 2x minus 1 equals 49. One's name rhymes with Schmoen. And then Schmarkus. You know. She knows Schmoen. Anyways, so we're going to do what next? What are we going to do next? You're not even sneaky. You're just right in front of my face.
He doesn't even care.
I have the right answer.
Your marks care.
Because I can double check my answer.
Okay. We're going to add 1. We're going to get 2x equals 50. And we're going to divide by 2. X equals 25. And what must we always do at the end? Check, because sometimes we get an answer that looks like it works, but when we plug it back in, it's what? Yes, there we go. Okay, so we check always into the original. We don't check into anything we touched. So the original is 5 plus 2 times 25 minus 1 under the square root equals 12. Do you see how I typed it right into the question? It's typed right into the question, right, Riley?
Yep.
Yeah, totally.
And now you go 25 times 2.
That's what I'm going to do. And now what you're going to do is take the phone here and put it in your backpack. That's where it wants to go. It's like, please, backpack. Oh. So we have 5 plus the square root of 49 equals 12. 5 plus 7 equals 12. And 12 equals 12. And it works. And we're happy.
So disrespectful.
Thank you.
I'm joking.
All right.
Thanks, Lauren. She's on my side here.
She was. She wants to do well. All right. Girl, please. All right. 5 minus n has to be greater than or equal to 0. I can move the n over by adding it. So 5 is greater than or equal to n. So n is less than or equal to 5, technically, because you read from the n. Okay, our first step is to isolate the radical. So we're going to subtract n. What's our problem actually, though? The radical is a negative in front of it. How do I get rid of a negative in front? Divide by -1 every term. So I'm going to get square root 5 minus n equals 7 plus n. And now what am I going to do? Square it. So I'm going to square this side, square it, and the square root cancel. I'm going to square this side, and when I square, what do I do?
Write it out.
Cross out the square root and rewrite it. Yeah. So you don't forget to FOIL. So we're going to get 5 minus n equals 7 times 7, which is 49, plus 7 times n, which is 7n, plus n times 7, which is 7n, plus n times n, which is n squared. When I have an n squared or an x squared or a square root of any sort, what do I have to do? Get everything equal to 0 every single time. We're using last units. So we are going to subtract the 5 and add the n. So I get 0 equals, and then we're going to go squareds first. So n squared. And then 7n plus 7n plus n is 15n. 49 minus 5 is plus 44, which actually factors. What times what equals 44? Yeah, what plus what equals 15? 11 and 4. And I don't even have to do decomp. 0 equals n plus 11, n plus 4. Then I learned this year that I have to set them equal to 0 each. So the only new thing. And then n equals negative 11, and n equals negative 4. I don't box them because I have to do what first? Check, 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 check. So the original, glad I can't hear you. Safer that way. N minus 5 minus n equals negative 7 minus n is what I need to check it into. So I'm going to go and check n equals negative 11 first. So I'm going to get negative 11 minus the square root of 5 minus negative 11 equals negative 7 minus negative 11. So I should get negative 11 minus, this is the square root of 16, which is 4.
How did I get to minus 7 minus negative 11? Isn't the original equation we're doing?
Yep, here's the original.
That's not
That is.
7 minus n. That wasn't there before.
There's no minus n.
You cursing.
Luckily, I'll still survive. Okay. Equals negative 7. I get negative 15 equals negative 7. Is that true?
Nope.
Okay, that's not true. Thank you. We agree. All right. So I circle this. I put a line through it, and I say
Extraneous or whatever.
extraneous. Then I have to check the n equals negative 4. So I go negative 4 minus the square root of 5 minus negative 4 equals negative 7. Negative 4 minus the square root of 9 equals negative 7. Negative 4 minus 3 is negative 7 equals negative 7. So this one's good. So that would be the solution. Now, like I said, sometimes both work. Sometimes one works. Sometimes neither work and they're both extraneous. When you're done that, can you flip to your notes, please? Page, I think it's 8. We're doing task number 4. Basically, we're going to rearrange the equation so that there's a radical on either side. Okay? There's 2 extra steps when you have a double radical. So I'm going to write this on the page beside it. So we have square root x plus 6 plus square root x plus 1 equals 5. So with a radical, with a single radical, our first step is to get the radical by itself, then square it to get rid of the radical sign, then solve. It might be a quadratic or it might be a linear, but we solve it. When it's a double radical, your first step on the paper, it tells that to you, is that you have to get the one radical on one side and one radical on the other. Okay? So I'm going to subtract this one over. You will have a double radical question on your test. You will have a double radical question on your test. So we get square root x plus 6 equals 5 minus the square root of x plus 1. And it might be in a written response section.
So it doesn't work to just square both sides?
No. You will have to in a second, but you need to move one radical to the one side, one radical to the other. If not, you'd have to FOIL 2 radicals because you'd square both sides and you'd have to still have a binomial just with radicals.
I just take it.
Well, you'd have quadratics underneath. Yeah, exactly what I thought. So, one radical on one side, one radical on the other. Then we square both sides. So I square this side. This side's wonderful. Why is this side wonderful?
Because it's only
One radical. So it's going to just cancel. What happens when we have a binomial squared? Cross out the squared and rewrite it, which means you're going to actually have to FOIL. So when you're doing a double radical, what you're going to actually do is you're going to do the double radical, and then you're going to end up with a single radical and have to solve it again like we just did yesterday.
Interesting.
Yeah. So this one's going to cancel this off. I'm going to be left with x plus 6 equals 5 times 5, which is 25. Then 5 times negative root x plus 1 is negative 5 root x plus 1. Negative root x plus 1 times 5 is negative 5 root x plus 1. And then minus a root x plus 1 times a minus root x plus 1. Minus times a minus is a plus. Root x plus 1 times root x plus 1 turns into what? X plus 1. Because when you square two roots that are the exact same together, the square root sign goes away. So it'll be x plus 1. And you can put it in brackets, but I have a plus sign in front, so does that affect anything? No. If I had a minus sign, though, then it would distribute through. So I don't need to because it's a plus sign. I can just write it as x plus 1. Now I'm going to collect like terms. So I'm going to get x plus 6 equals 25 plus 1 is 26 plus x. And then these are like terms, so I can put them together. Minus 10 root x plus 1. Now I have a single radical. What's my rule when I have a single radical? Isolate it. So I'm going to let that sit there for a second. And I'm going to subtract 26 and subtract x. Let's move it over here. So I'm going to get 26 plus 6, which is negative 20. And then the x's just cancel. Equals negative 10 root x plus 1. Now what do I have to do? Bigger. Divide by negative. What's the number in front? Negative 10. So divide by negative 10. So I'm going to get 2 equals root x plus 1. Now I isolated the radical on one side. What am I going to do? Square it. The squared cancels with the square root. 2 squared is nice. It's just 4. Equals x plus 1. And then what am I going to do? Subtract 1. So I get x equals 3. What's my last step always? Check. Back into the original, which is on my whiteboard over there. So we'll go square root 3 plus 6 plus the square root of 3 plus 1 equals 5. So we get square root of 9 is 3 plus the square root of 4 is 2. So we get 5 equals 5.
4 doesn't have a square root.
It does.
Yeah, it does. Square root of 4 is 2. Okay,
How do you state restrictions?
so that's what I'm going to do next. So when we go to state restrictions on this one, we have x plus 6 under one of the square roots. So we have to say x plus 6 has to be greater than or equal to 0. So x has to be greater than or equal to negative 6, because I'm going to subtract 6 over. But we also have x plus 1 has to be greater than or equal to 0. So x has to be greater than or equal to negative 1. Those are my two restrictions. The catch when you have two restrictions, because we had two radicals, the catch when we have two restrictions is one of those restrictions will cover the other one. So I don't have to actually state both. Which one of these covers the other one? X is greater than or equal to negative 6, or x is greater than or equal to negative 1? Negative 6. I'll show you how. If it's greater than or equal to negative 6, that's this. If it's a number line, all the way to here, correct? If it's greater than or equal to negative 1, that would be here and here. So if you look, the negative 6 actually counts the negative 1 as well, doesn't it? So I only have to state this one. because it actually states the negative 1 in it as well. Then we're going to look at the next one. So the next one is square root 2x plus 4. We'll do this one together as well. Square root 2x plus 4 minus root x equals 2. When I have a double radical, what's the first thing I have to do? Yeah.
One radical on each side of the.
One radical on each side. I'm going to move the subtracted one because then it's going to be added, and I like adding better.
That's one.
So I'm going to add the square root x over. So now I have root 2x plus 4 equals 2 plus root x. So I have to get one radical on one side and one radical on the other. That's the first step. What's the second step? Square both sides. When I square a square root, this one's nice. It goes away. When I square a binomial, what do I have to do? Yeah, cross out the 2 and rewrite it again. If you do that every single time you have a binomial, you will never, ever, ever make a mistake in grade 11 or 12 or onwards. It happens in 12 as well. When we square a square root, the square root sign goes away, and I'm left with 2x plus 4 equals 2 times 2, which is 4. Then 2 times root x is plus 2 root x. Then the inside, 2 times root x is plus 2 root x. And then I get root x times root x. When I square two things that are the same, or when I multiply two radicals that are the same, you just get x without the square root symbol. Yeah. I'm going to collect like terms. 2x plus 4 equals 4 plus x plus 2 root x plus 2 root x is 4 root x. Now I have a single radical. Now I use all the rules from yesterday. When I have a single radical, what do I need to do? Isolate it. So what do I have to move? The 4 and the x. I'm going to minus 4 minus x. Minus 4 minus x. So I'm going to get negative 4 and 4 cancels. 2x minus x is an x equals 4 root x. Now I'm going to show you something. Every other time we've done this, whatever the coefficient in front was, divided over and it worked out evenly, correct? Like the last one, we divided the negative 10 over and we got a 2. It worked out nice. If I divide the 4 over, is it going to work out nicely? No. So sometimes dividing it over is not the better option. So if I divide the 4 over and it doesn't go in nice and I'm stuck with a fraction, instead of dividing the 4 over, I'm just going to square both sides right now. So if I divide the 4 over, I get a fraction, which isn't as helpful. So I'm going to square this side, and I'm going to square this side. Now the problem is, this side squared is x squared. That's nice. This one people will try and FOIL. Is there any sign in between here to FOIL it? No. So we can write it out twice, which is what I told you to do. But we're just literally going to multiply front times front, back times back, right? So it's going to be 4 times 4, which is 16. And then root x times root x is x in brackets. So you just end up with 16x. So now I have x squared equals 16x. And when I have an x squared, I need to move everything to one side. Set equal to 0 every single time. So I'm going to subtract the 16x. So I get x squared minus 16x. And then people freak out because I can't factor it. If you were stuck you could put it into the quadratic equation as a would be 1, b would be negative 16, c would be 0. You could plug it in there. But if you, no, you can't do difference of squares because the x on the 16 isn't. But you can, instead of difference of squares, you can actually just take out a GCF because there's no constant. So I can take out an x instead, and I just get x minus 16, and then I can set each equal to 0. It's actually faster. So when there's no constant, when there's no c value, you just take out a GCF. So now this one's going to be x equals 0. And this one's going to be x minus 16 equals 0, x equals 16. And then what do I have to do? Check them. So I'm going to check x equals 0 first. I plug it into the original, so square root 2 times 0 plus 4 minus square root 0 equals 2. 2 times 0 plus 4 is square root of 4, which is 2, minus square root of 0, which is 0, equals 2. 2 equals 2. It works. And then I have to check x equals 16. So I get square root 2 times 16 plus 4 minus the square root of 16 equals 2. 2 times 16 is 32 plus 4, it's 36. Square root of 36 is 6. Minus square root of 16 is 4 equals 2. And you can show the work in between if you need to. 2 equals 2. Wait a second, both of them work. Which can happen, right? I told you, both can work, both cannot work. One can work and the other one cannot work. They're both the answers. You're going to try C. Or the third one. I think it's C. Oh, I forgot to do restrictions. Good call. So this one is going to have 2x plus 4 has to be greater than or equal to 0. Move the 4 over. 2x has to be greater than or equal to negative 4. Divide by 2. X has to be greater than or equal to negative 2. That's the first one. And then your other one is just an x. X has to be greater than or equal to 0. Which one of the two encompasses both of them? This one. Because x is greater than or equal to negative 2, that's like this, negative 2 and greater. And then 0 would be here and greater. But it's already covered by the negative 2, right? So you just use x is greater than or equal to negative 2 as your restriction. You're going to try the third one. Yeah.